part residing on my headquarter, I want to manage all the branches which we have currently. In future, if I want to add more branches, more devices, less effort, complete function we want. So we require this SDN. So Cisco provide three support for SDN. One is called your data center. In the data center, device is our ACI and controller is called APIC. Another part we have that is similar for our campus. Campus part is called SD access. Our controller is DNAT. Why I'm explaining this before SD-WAN? We have lots of similarity in between. ACI and data center part now, SD access part, lots of similarities. And then another thing, so one part you can say why we are preferring this particular thing, data center to the campus network. We want to read out from the L2 technology that we do not want STP interference. We want redundant link, but that should be layer 3, not layer 2. We do not want layer 2 loops. We want fast convergence, complete redundancy, high bandwidth utilization. So both things are here in this particular part. Another solution what we have, which we are going to start, that is our WAN part. WAN part, Cisco provides solution of SD-WAN, and in the SD-WAN, our controller is once in future, if you will get complete authority of this particular, how actually it is going to work. We are actually integrating all these three controllers, and we are getting the proper. Okay, I think 1 and 2 also joined right now. All right, guys. So it's my suggestion to everyone, please join on time so that we can utilize and understand multiple things. Okay. Now, what all things we need to have knowledge so that we will able to understand this function. Particularly, let's concentrate here for our SD-WAN. This is called SD-WAN. Okay. For SD-WAN, first thing we need to have the knowledge, what is traditional network? How traditional network works. Some of you are already mentioned that you are in the networking domain, taking care of router and switches network, firewall part. So we are aware with this part, though we will discuss what is traditional. So I think most of you have mentioned that you are having knowledge of router and switches, correct now? Particularly routing fundamental, how router works. Is this clear to everyone? Yes or no? I think this part clear to everyone now? How router starts its function? Yes, say something. I will not asking and I'm not asking anything. I just want so that I can start the procedure. Yes, now. Hello. Marince says yes. What about others? Routing fundamental, you know how router works, what is routing table, each and everything. I just want this thing. Please say something. Anyone? Abhishek? Yeah? Naren? Anyone? Then you are everyone aware with this part now?
Yes.
Yes. All right. Good. So see, when we are discussing the routing table, tell me the component of routing table. I'm explaining this part. What is control plane? What is data plane? Management. Okay. This plays major role. It's control plane. How control plane functions? This thing I want to. Anyone will provide me this answer, how control plane is going to work? Pinku also joined right now. So Praful sir, I think those who have enrolled, now all, everyone joined? Yes or no? Or still one and two left here? All right, guys, comes here. What is control plane? How control plane? What is the function played by control plane? I just want to know this thing. Anyone will explain this part? What do you mean by control plane? What is data plane? What is management plane? Yes, sir. Everyone join now? That's good. So though I have just also you have mentioned in the group now, I think yes, total candidate what was there? 1, 2, 3, 4, 5, 6, 7, 1, 3, 4, 5, 6. Okay. So Praful sir, do one thing. Just in the group now, please mention the email where I will submit the recording and accordingly you will share with them. On the email. Okay, so I will take. Okay, so share with me. Okay, otherwise I will take it from Abu sir, inform me. He will share me the part. I will share that recording, everything, document accordingly, and then they will get each and everything from. That's good now? All right. All right. Okay. Thank you, sir. All right, guys. I didn't get the answer. We know the routing table. We know what all information we are verifying in the routing table. So what the information we are verifying in the routing table, it is divided into three subparts. In SD-WAN also one plane will comes into picture. Right now we have, sorry, a spelling typo mistake is here. Control plane, data plane, management plane. Yes. So where to send traffic? Data control plane, data plane, forward traffic. Okay, Naren. Understand in this way. The function of control plane is which generate and insert signals for destination address on source router. The number of alternate path we have. The entire topology information. And source router receives all routers route information in the particular given topology that is taken care by the control. And you mentioned data plane is forwarding plane, good. But data plane verify next hop information on each and every hop as per instruction received from control plane. It's the work of control plane to inform data plane from source to destination, which is the best path, which path selected by the routing protocol algorithm, and that path you need to follow from source to destination. Give me one moment, I am opening one part that will help you to understand. Just one moment. Control plane not only generates signal and insert destination route information every source router, it also kept entire topology information based upon that as for routing algorithm mechanism, best path decided, and it informed data plane what the next hop you need to verify which path you need to follow. So that part comes under our control plane. So here I am having one thing that is this is the best topology. We are going to understand. See, we are discussing something, that's why I've opened this particular part. Here I am understanding router 11 is the source, router 12 is the destination. And these number of router we have. Almost type of full mesh topology is here. And I am running OSPF in between. So When router 11 user try to access router 12 user, when router 1 will receive the request, so what router 1 will do? It have the option to submit on router 2, on router 6 and router 14, router 4, right? But SPF uses shortest path algorithm, SPF. So it will choose either this particular path, it will choose either this particular. So one option is also from here, it can go there. This path, maybe a one hop is more. So it can discard this path. So this is the function of control plane. So when this user will tell, it will inform next hop, which is the best path we need to follow. That is taken care by the control plane and data plane forwarding. So Naren, what about management plane? What the work performed by management? Even will explain when we want to take remote access. That's good. I am having one answer here. SSH telnet extra 100%. If we want to take remote login and provide support to our client when we are taking telnet and SSH. So that part is taken care by the management. In SD-WAN, we will also learn, we will go through what is orchestrational plane, right? So now tell me, what is traditional routing mechanism? When router 11, user will try to access router 12. In traditional routing, the number of devices we are discussing layer 3 device. Okay. Yes, Vaibhav, Telnet, SSH are part of the management plane access. Good. 100%. So traditional routing means route lookup occurs on each and every way. Means every router will perform the route lookup. They will perform the function of control plane. They will perform the function of data plane. They will perform the function of management plane. So one major purpose of your SD-WAN, the one major purpose of our SD-WAN to decouple the function of control plane, which is going to decouple which device is responsible for control plane, for management plane, and for data plane, for management plane. We will discuss how these three devices will function. What is orchestral plane also we will discuss later. Not concentrate on another term. All of you are maybe, I think those who are working particularly in the firewall, 1 and 2 mentioned here, you are aware with the function of BPM, correct? So those who are working in the VPN platform, particularly on the firewall, actually the major function not only to recognize inside outside traffic, verify the security level, we are also implementing NAT and VPN. That is the major work performed on router, correct? So anyone can explain me what actually VPN is, virtual private network? Why I'm explaining this term? These terms are very important when we are going to understand SD-WAN terminology. What all things we need to have the knowledge for SD-WAN? Let me discuss this thing. Our BGP fundamentals should be sound, otherwise little bit function. OSPF should be there. We need to have knowledge of MPLS. Apart from that, VPN functionality, different way it is working, but we need to understand. So anyone can explain, could you please explain what do you mean by VPN? What is VPN? How VPN works? What are the things we need to understand for the VPN? Little bit. Very basic functionality. Yeah, anyone please?
So it is
Yes, sir.
technology that creates a secure encrypted tunnel over public IP. Public network,
Encrypted tunnel via public IP. Okay. So you're okay, fine. Yeah, Abhishek, you also want to say something. Yeah, please.
Ye- Yes, virtual private network is usually when we have to communicate between two sites over the public network, and we want to secure our data traffic in such that no middle attack should be the means harm it that traffic. So that so VPN majorly three things it does. One is
Hmm?
authorization, authentication, and encryption. So by three things, it works majorly and secure our
You
thing. Yeah.
mentioned triple A function.
Yes.
Actually, you are sure that triple A is the part of the VPN? Without ICE, will triple A will work? Okay, forget about that part. Now tell me, this is the ISP internet. I am having X location and Y location. Correct? Here I am having one private IP 10.1.1. This network I am having here, or better to say 10.1.1.0 C area 24. In the Y location also I am having 10.2.2.0 C area 24. How they can access each other? We need to bypass our space domain. For that we are going to create tunnel that is called GRE tunnel. 100%.
Yes.
So GRE tunnel is the secure part.
No.
Yes or no? So
No.
no need to say VPN is for security. We need to say VPN is the function where two location of the private user communicate while going to bypass ISP's network. How to make the secure partner? Then in VPN we are applying IPsec fundamental, whatever the IKv1, IKv2 functionality is there. So VPN purpose is right. Our different location private user can communicate. Yes, for that we are creating GRE tunnel, and then tunnel part our information remains in the plain text. Over tunnel we need to apply IPsec. Then security purpose. First is what is the function of VPN? Good. All right. This VPN, when we are going to understand SD-WAN part, our controller interfaces are the part of VPN. There we have transport VPN. There we have management VPN. There we have service VPN. Okay. So here interfaces are going to become the part of VPN. Accordingly, we are applying the things. All right. I think you are aware with the VPN function. You are aware with the DM VPN, dynamic multi-point VPN. Anyone got the chance to work on the DM VPN? Yes or no? Anyone practically work on the DM VPN functionality? Just say yes or no.
No.
So DM VPN is a function where in future if we are going to add multiple branches, in future we are going to add multiple branches, we do not want to apply that fundamental every time on our, you can say, headquarter of. So DM VPN, if we have one headquarter and if we have 100 branches, so one-to-one tunnel is not possible. So dynamic multi-point VPN is the function where one-to-many, look, one-to-many part is the part of multicast. Yes, we are implementing multicast function DM VPN so that if we have one headquarter that we are calling hub and we have multiple branch and these are connected by the ISP, instead of creating one-to-one tunnel, dynamically our spoke router is going to find our headquarter. I'm going to show you, understand this way. Uh, Side to side VPN is there. VPN will be there in this part. Yes. It's 1 minute. We have the headquarters, that is hub, and then we have these branches 1, 2, 3, 4, 5. Just for example, in future, if we want, we can add another branches also. So these branches are going to find tunnel dynamically using next hop resolution protocol NHRP, and hub is not going to mention what is the destination. Destination paths become the GRE multipoint using, we are enabling multicast functionality there, and then automatically they are going to find tunnel, form tunnel. Not only this part, once we are implementing phase 2 now, so spoke to spoke tunnel is also going to create. Why I'm explaining this part? Once we learn your SD-WAN function, the number of branches we are going to design. So branch to branch tunnel is going to form automatically. We are not going to configure that manually. So type of this function is there. We need to have the knowledge of IPsec, how IPsec works, that part also there. Automatically IPsec will comes into picture, encapsulation part. It is going to take care encryption part, everything. So that part good. So now again terms here, why we required SD-WAN? Because if we are going to discuss the traditional network part in this way, see, for example, every organization is going to, who is here right now? See, right now you joined here? Yes, all right. This is our traditional network. Actually, we are connecting our ISP's part on firewall, because firewall capable to recognize inside outside traffic, which is secure, which is unsecure, what is DMZ zone. So we are going to configure ISP's network on the firewall. From firewall, we are going to connect router. From router, we are going to connect L3 switch. L3 switch, we are having multiple L2 switches. This is just an example of that particular part. And here we are having full mesh connectivity remains there. And then we are having end devices here. All end devices remains connect, and then between layer 3 switch and router we are connecting load balancer also. The number of firewall, number of router, layer 3 device, load balancer, L2 device. What we require in the traditional network, we need to configure them manually. This is the part of suppose one location. We may have multiple locations everywhere. If in future we are going to add more devices, it need to configure manually. We do not want this thing. And another thing, all layer 3 device is going to perform control plane, data plane, and management plane. Separate device for each and every part, so that from one particular site we are going to manage every resource of the branches. In future we have zero touch provisioning. Once we are going to have template, means set of list, that set of list in future, if other branches are going to add, we will apply that list to them. We doesn't require new configuration. Single place of glass, we want to do the configuration. That purpose we required SD-WAN, software defined network. From head office, if we have multiple branches, all branches, we are going to manage from one central point. If we don't have the proper engineers there so that they can run our command, so what actually we will do there? We will just run a script. Based upon that, we can manage each and everything. SD-WAN another part says that is our transport location. So we have two set of connectivity. We are managing SD-WAN. One is called private and one is called public. Here we are not going to use Ansible Puppet chip here, Naren. That part it comes under Epic. This is the part of SD access, not the SD-WAN. Okay. What you are telling the Ansible Puppet chip, Ansible is the Cisco part to manage control Epic through Epic. That is not the part here. That is the part of your SD access, not the part of SD-WAN. Okay. Okay. Private and public net. One moment. Here this terms comes under MPLS. Public network parts comes under internet. For private network part MPLS, we will configure OSPF. Internet part via default routing, we are going to configure the tunnel. So tunnel plays a major role here. That we will understand. So how this tunnel is going to work? First, in your SD-WAN, our controllers are virtual. These are virtual devices. These are not the physical device. Physical device required license for the Nexus part. Other part also we require the license device for firewall also. But if we are working on the physical device, we doesn't require to have certificate. Our controller is the SD-WAN, they are virtual. If we are talking about the physical device, that is called virtual physical device. Means though it is hardware, but we need to have certificate for them. So Bashu, today is the first day. We are just going to understand what all things we will cover. Then tomorrow, what are the command syntax, what are the total controller we have, how that is going to work, and then we will try to establish the lab part. It's fine. But my suggestion to everyone, once we have decided any class time now, please join on time. Then though you will get the recording, that's good. But from the starting, it will help you. So please maintain the time. So this virtual device is required.
Hi, Kundan. Sir,
Yeah.
could you please explain about the private versus the public once again?
We will
It
discuss
will
that.
be
I
very
will
helpful.
explain you. I will explain you again. I will explain you little. So I will
Sure.
explain you. See, now understand in this way. For our sake, try to understand. Suppose here is our head office. We have controller in our head office. Okay. These controllers we are going to connect with the switch. From switch we have a device and our controller are connected with the switch. These are the controller are the virtual devices. We are connected with a physical switch to that server where my controller is going to install, and then we have a router. So this router is going to connect with the two ISP. One part we are mentioning here as a private and one part we are mentioning as a public. So remember one thing, I will say in SD-WAN now, We have the option to use two private network at a time. We have the option to use, but we require redundant link, alternate link. If one part is going to went down now, and these are the network, these are my branch devices. Suppose we have branch 1, we have branch 2, we have branch 3, and we have branch 4. So ideally what we are doing, we are connecting them, all devices, through all network. So system now, we are private part, we are understanding through MPLS, public part, we are under the internet. So from this part, from branches to the private part, we are running routing protocol. For here, branches to internet, we are running the tunnel, we are creating tunnel. So we want redundancy. And suppose if we do not have these two connection on any branch now, then we are extending that is called transport locator, TLS, T-lock extension is there. So that logically, though we don't have the physical connectivity of two ISP redundant path there, logically we are having that connectivity. That is called your T-lock extension. So we need to have two internet connection. Like when two devices in the production and two switches are going to connect, what we required? Two link. From router to router also we are preferring two link. If one part become unavailable, another link remains available. Yes, no? Same thing here.
HAP.
Yeah. High availability part. If one part become unavailable, do we have the redundancy so that we can implement our traffic engineering there. After that, if we have the redundant path, if entire traffic utilize both of the path, equal cost, multi-path, fine, let it to be there. But why not to segregate the traffic based? Some traffic we want to handle by my private network, some traffic is going to handle by my public network. That only possible if we have two redundant links. So both links we are not preferring internet path because that IPsec is the functionality, MPLS is the different part, so we need to understand. So what we required, so we have multiple private concept there, multiple public internet concept there. I will show you each and everything, what all options available in the public, what options in the private. Not only that part, I will share you relevant document for that also, so that after the class, you will go through that part and you will try to understand how that is going to work. So this is called our two network. We require redundancy. We are not preferring two public at a time, two private at a time. If my tunnel part is not working through a sphere BGP part, we are having neighborship with MPLS. If MPLS is not working, at least we have the redundancy. That's why we require two things, okay? And this call our T-lock extension transport locator. How transport locator works, we will understand. What is dynamic tunnel, DTLS, data link, transport services. That we will understand. What is OMP, we will understand. So let's understand some basic part. What my part is that if I want to learn SD-WAN, first thing, my routing switching fundamentals should be sound. Another thing, we need to have knowledge of MPLS, we need to have knowledge of BGP, that part good. Our IPsec fundamentals should be sound. And little part of quality of service mechanism we have so that we can decide which traffic will get priority. One thing. Another thing, if we want to, first thing is required certificate. To generate certificate, we need to have Windows Server knowledge. That part of, so Windows Server we are generating certificate. Now you can ask me one question, why we required Windows certificate? Why not through the Cisco part where we have the software control mechanism, directly we can put certificate there. But organization is not preferring. Why? We do not want to have completely rely on the Cisco part. Smart account part, we have the option to push the certificate from a smart account. We are getting the activation of device, the number of branch devices we want. For that, we require our smart account. Through smart account, it's very easy to push the certificate. That's good. It's very part. But actually, where our dependency is on the Cisco account part, a proper security part is not going to manage, and anyone will remove my certificate from there, our SD-WAN functionality will stop. If we don't have certificate, means activation is not there. So what we required, how Windows Server work properly. How Windows Server work properly, which steps is required so that we can generate the certificate. We need to generate certificate, we need to sign certificate, we need to push certificate. So this is the one thing. One by one people are joining. Right now, who is here? Ahmed. So, Mohammed, you joined too late. Why?
Hi, sir.
Yeah, you joined too late. Why?
First, it's different time. Second, we have war in our country. I'm from Lebanon.
You are from Lebanon now. So are you
Yeah.
working there? Are you working there?
Yes.
So right now, what your job timing is? Okay. So
I
look,
don't have I don't have work today, but we are in war. So there is some problem in the internet connectivity.
okay, no issue, no issue. So try to be on time so that from basic part you will get recording part, go through that part. Those who are joining later, and if based upon that, if you have any issue now, we will discuss that. Okay,
Okay.
that's good. So if you don't have the knowledge of Windows Server, how that is going to work, every step I will show you properly. So if I want to generate certificate, we need to have some basic functionality. Okay, one thing I think everyone is aware with the part, one is called underlay, one is called overlay. I think you heard this part now. What is underlay, what is overlay? Yeah, I'm having message there. Yes.
Yes, yes.
Underlay means we are creating physical connectivity. Once our physical connectivity is going to complete, then overlay part we are executing our tunnel stop other functionality. So when we are discussing VPN partner, if we are going to configure GRE tunnel, before GRE tunnel what we required? From ISP part to my branches, we need to have physical IP connectivity. Based upon that, once we have the reachability, so that head office, that is hub and spoke, if we have physical public IP connectivity, once underlay is going to have, then GRE will comes into picture. So underlay overlay plays a major role. Underlay means physical IP connectivity, making the physical topologies to work properly. Based upon the physical topologies, then we will understand what is logical topology. That plays major role. So once we are understanding VPN here, it doesn't mean I'm going to enable IPsec manually here. No. Our interfaces comes under there. So normally we have the knowledge how to work on router, how to apply configuration on switches, what all things we need to work on the firewall, correct? Most of you are aware with this particular. On the virtual devices, before going to generate the certificate, we need to do some initial configuration that is called skinny configuration. We need to understand this part. Once skinny configuration will over, we will do again one person join. Who is right now? Ishal. Okay. some basic connectivity that is called skinny configuration. So when we want to activate and configured our virtual devices in our SD-WAN, what we required? We required organization name, we required time zone, we required system IP, we required site ID, and we required, we will discuss what devices we want IP, and then we required that you can say VPN 0 and VPN 512 connectivity. That comes our skinny configuration. After that, we can start. So how this is going to work? On global mode, we need to use command that is called system. Under system, we need to configure this thing. So my part is that your VPN, MPLS, OSPF, BGP, tunnel, basic switching fundamentals should be sound. Then you will able to understand all this particular part. From skinny configuration, okay, on controller narrates. So see, we have control plane device in the SD-WAN. That is first understand management plane. That is called vManage. Then we have our control plane. Control plane is called vSmart. After that we have data plane. Data plane is called VH. After that we have orchestrational plane, authenticator. That is called V1. So vManage, vSmart, and V1. These are 100% virtual device. They required certificate. Now for VH, we have two options. That is Viptela, you can say. Now Cisco doesn't support Viptela VH, it's still supporting CH. This CH is Cisco ASR, you can say CSR or ASR series of physical device, but they are physical come virtual device. Though we have physical box, but this physical box requires certificate. That is called onboarding. So either therein we are going to configure vManage, vSmart, vWAN, VH, either it is CH. We required skinny configuration. Skinny configuration, different option available in the CH, but same option available for the vManage, vSmart, and vWAN. So that your configuration will not work. Yeah.
CSR or ASR is the router type.
Okay, I'm explaining this part. See, guys, you know, Cisco operating system is called router or IOS, Inter-Network Operating System. This operating system, two functions we have. One is for enterprise, one is for ISP. For enterprise, we have iOS XE is called there. ISP part is called iOS XR. So where router works on the ISP domain, that is called POP. So iOS XR, we have integrated service router, we have core service router, we have aggregate service router. Previously, we had GSR gigabit switch router. Now Cisco migrated GSR into ASR. So ISP's domain practically is called point of presence. There we have three set of router parts, device part. One is called provider edge, one is called customer edge, one is called provider. So there we are using these setup router. So now this ASR and CSR, Cisco convert them into the physical box into virtual capability so that now Cisco purchased in 2017, Cisco purchased Viptela company, and that is become our Viptela SD-WAN. Now it is Cisco SD-WAN. So we manage vSmart, vBond is as it is. Instead of vEdge, now Cisco supports only CH. And that part mostly CSR and ASR. So these router ASR is very capable router. If you will learn in future data center, and there we have one function that I maybe heard about the term, that is VXLAN. So this can implement on Nexus, this can implement on ASR. So yes, if we want to recognize ourselves in the hardcore production domain, not for troubleshoot, for the design implementation, everywhere. Right now I've explained now I work for the Access Bank data center for our multi-pod and multi-site to manage all other switches. We required this ASR, aggregate service router. They are the chassis-based device. There we are having line card, and every line card is going to have fiber optic multiple SFP. Based upon that, that function is going to work. So yes, these are the Cisco high-end devices which Cisco recommend for the CH part. Okay. I think you are aware with the enterprise part, ISPs part, XC, iOS XC, then iOS XR, XC part. Right now, which device is working? So this
So
is
if it
not
is
the
good,
part.
it is repeated means no worries.
That's right.
It will
So
be
this
helpful
part,
to understand again. Yeah.
yeah, that's part I will like. I'm explaining this thing. All right. So let's understand a little bit, guys. Here, when we are discussing enterprise level of the part, enterprise means in our hardcore network domain, we are providing support to banking sector, insurance sector, automobile industry, airport authority, share market, educational institution. So we are working on switches. Okay, we need to have command over switches. We require very less router there. So what router works for enterprise level? Currently we have 3900 series and 7600 series. This 3900 series, so onward these devices, they consist two things. That is called route processor and switch engine. It means we should not VLAN there. And that option of VLAN means we can add switching slot. So we are verifying the production environment, how many route processor switch engine we have, what is their capability. Based upon that, these function can implement it. So that introduced from the Cisco onwards 2800 series of router. 2800 series of router having this functionality of the VLAN. After that 2900 series of router from the Cisco dedicatedly for the IPv6 part. Lots of new requirement comes. So Cisco is not supporting right now 2900. Now we have 3900 and 7600. In your production environment, we have two things. One is called end of sale, one is called end of license. Sale comes means we can't order the new software. End of license means we are not getting any new patch update. So now in production part, we are not, those who are working is their choice, doesn't matter. When we are designing company network, it's very important. What is the end of sale and end of license? After that, we need to upgrade that part, that is called migrating current in what information configuration part to the new part, how that is going to part, that is called the migration step. I'm going to show you one thing that will help you see here. For that, we have one tool. Will give me one moment. See the option of 26. One way 2600 series router, Cisco at the time developed SDM functionality so that graphical user part we can take it easily. Then that was 2800 series. If you will open this part now, I want to show you this thing. Let this open and let this 2900 anything. See, VLAN 1. Obviously, VLAN is the part of L2. It is not the part of L3. What does this mean? In 28 onwards, Cisco developed the concept of that concept was available on the switches part 4500, 6500, that was the multi-layer switch. They consist route processor and switch engine. Backplane speed, redundant hardware, that was in the multi-layer switches. In the traditional network core layer, we were using 65. Then distribution layers 45 along with the 37. And then 2960 in the access layer for the end user. Now Cisco doesn't support this 45 and 65 more because they are not capable for fabric part. Means if we want to do the LAN automation, it is not possible there. That's why now we have 9000 catalyst devices which are capable to work with starting from 3850 series. So this part, little bit we have, you can say, that is route processor switch ending, switching slot, maximum 16 switch port can assign configured here. So routing as well as switching functionality, this device 2811 is capable. After that, we have this 2900. Thing you're finding here. Actually, it supports gigabit gigabit, not fast Ethernet. And I think you are aware recently Cisco tested the gigabit Ethernet for the USB port 800 Gbps right now. Cisco got this part. So this is also for, and this 2900 series dedicatedly for the IP version 6. But it was not capable to handle entire part. So now we are using 3900. Previously we had 7200. Now we have migrated 7200 in 76. So this 39 dedicatedly for enterprise, that is iOS XE part. This 76 or 2 part, XE as well as XR. That XR means it is also having part of the ISR integrated service route. So this thing we have. So we need to have little bit hardware specific knowledge. That's why I explained this part. It's good now. If we are discussing something, some part to understand proper functionality, I think it's good to everyone. Otherwise, we will discuss completely on the SD-WAN. So little bit I have explained. No issue now. Everyone, please say.
Thank you, sir.
Yeah, no worries, sir. Thank you. Thank you for remembering us.
So see, this part is here. And then your CSR part. In the CSR, we have mostly 900 series. And ASR, we have 1000 to 9000 series. This 9000 series, now let me explain one thing. Lots of very confusion is there. Nexus part, also we are using 9K. Catalyst part, also we are using 9K. Your fabric extender, when we are using Cisco UCS, we are also having, there we are having 6K. Yeah, that we have the 6K. But catalyst part also we have 9K. So it's very important. Either we are working on the Nexus environment, either we are working on the catalyst environment, and one part is also there. One is called 8000. 8000 is catalyst, 8000 is virtual, 9000 is catalyst, 9000 is virtual, 1000 part, it is CSR part, it is also virtual. So this way actually, right now Cisco recommending 8000 V part of the CS part, so that new part, ASR part, we are working. So if we want to get authority in a little bit, this hardware based knowledge is very important so that we can understand. So current part, I am explaining one thing, what else we require in the current part. If everyone having knowledge of first BGP, that good. So anyone can say, what do you mean by MP-BGP? Those who working on the border gateway protocol platform. So tell me, what do you mean by MP-BGP? Multiple protocol BGP is what? Heard the term MP-BGP, yes or no?
Yes, sir. Yes.
What is MP-BGP then? Please little bit say, try to explain.
Uh, mm,
Abhishek, good.
yes. So in BGP, when we inject the routes of with MPLS comes in picture when we do the with route
MP-BGP
distribution.
not, no. MP-BGP means it is going to support all address family.
Oh, yes.
Sir,
Address family. Yeah, please.
it's no network in BGP and SD-WAN, or it's must. It's a must.
No need to worry. Look, what I required from my those who want to learn SD-WAN now, only thing what I required, your basic routing and switching fundamentals should be sound. You must aware with the routing protocol terminology, some of the switching terminology, that's only I required. Rest
Okay,
everything,
I'm working with OSPF or FHRP, not BGP.
no issue. If you are not working BGP, no issue. Only I am explaining what all protocols being supported by everywhere now. I am telling you this fact. See. Okay, let me explain. First, I will explain this part to you. Address family. How many address family we have? We have address family that is IPv4, unicast, and multicast. We have address family IPv6, unicast, and multicast. We have address family VPN v4, unicast, and multicast. We have address family VPN v6, unicast, and multicast. And apart from that, once you will work on the VXLAN domain, extending layer 2 over layer 3, we have one address family that is called L2 VPN eBPN. So only BGP is capable to carry the route of each and every part. And what you have mentioned, the MPLS part, you are good. What we explained, route destination user, route target, now that comes under VRF. VPN routing forwarding instance. We know that if we have 4 interface on router, what we required? Like here now, I think that part is open here. We have right now, you can say 3 interface. As for our understanding, these 3 interface need to configure with separate IP network. 10.1, 192, 168, 172, 16. If I'm working on the third octet, then every interface need to be in the different domain, different IP subnet, correct? It's not possible in the production environment. I've already explained now that your high-speed domain call is POP, where we have provider edge router connected with multiple customers. And this router we are using ASR. If I'm using ASR having two soup engine and we have 4 line card. Every one line card having, you can say, 20 SFP. So we are going to support 80 SFP, means 80 interface we have. If we are having this type of support and these number of customer I am going to support, it's not mandatory now. Though I am going to use different IP, separate IP. So rule says when provider edge router, multiple interfaces connected to customer edge or interface configured with one IP, that is called overlapping IP with the help of VRF, route distinguisher route target. It creates globally unique and route target value again carried by the BGP. That is import and export. Okay. So multiple protocol BGP means it's not part of the MPLS. When BGP is supporting all address family now, that is called multiple protocol. Every address family support we are having. Okay. So see, this BGP along with the MP BGP, then we required the knowledge of MPLS. We required multicast routing, complete authority. We required basic quality of service knowledge. We required access protocol knowledge. Then what we required? We need to have the knowledge of locator ID separation protocol. We need to have command over VXLAN. And then in the nexus part, what is VPC and apart from the ACI. Forget about this part. It's at least this till VXLAN knowledge we need to have in the current scenario. Then we will able to justify ourselves. What all things you will learn here, I am clearly mentioning you. Here we will not discuss what is BGP, what is MPLS, what is IPsec, what is tunnel. We will verify it practically. Some things will come automatically, some things we need to configure. Based upon that configuration, certain function will come. How to map the interface. So like if you will work on firewall, we require to configure interface. We require name if coming, right? Without name if it is not going to work. Name if inside, name if outside, name if DMG. That's why we are connecting firewall to ISP part, not directly. Same thing here. So our controller, like I mentioned now, we have management plane. That is we manage. It is the, you can say, entire part we are managing here. Then we have control plane. That part comes under V smart. Then we have data plane. Data plane part is our VH. Though we are using physical type of the virtual device CH, but it is called virtual edge. These are our branch part of the device. All branch devices connect with the VH. And then how this is going to work, who will authenticate them? That is called orchestrational plane. V1. Either it is vManage, vSmart, V1. They need to get the IP of V1. Based upon that, V1 will authenticate them. It is authenticator. Now, in SD-WAN, the term is called catalyst SD-WAN. What is catalyst SD-WAN? vManage is now called manager. vSmart is called controller. Few others are called forwarder. And vBond is called authenticator. Everything is fine. Certain options are changed. I will show you. And you will work on the new part of the iOS where we have this catalyst SD-WAN. What all options available from here to production life, everything I will show you. So this way it is going to work. So now question is that where we can have this vManage, vSmart, vBond. So we required servers, either for Dell or KVM part. So we required EXI utility where we can install vManage, vSmart, vBond. How they can get the certificate? How we will generate certificate for them? So these devices required certain configuration that is called skinny configuration. And this skinny configuration comes under your system utility. We need to type system. Under system, we are providing what all things? We are providing system IP. System IP means type of router ID, name of the particular router so that they can represent themselves to another. Then we require site ID, physical location, either it is head office or branch office. Basically, site ID required to deploy policies. This part over, we required vBond IP. We required authenticator IP. After that, what we required organizational name. You need to register yourself. We required time zone. This is the first thing. Once this part will over, then we have the interfaces. The interface which is going to connect pointing towards ISP, that is called transport VPN. It is fixed. That is 0. You can't manipulate that. Now, how this device connected internally, that is called management VPN. That is also fixed 512. So these two are the fixed part in our SD-WAN. You can't change this thing. After that, we have our service VPN pointing towards branch part. There we have option of 1, 10 till 511. If we have more branches option to authenticate, then we can move accordingly. After 512, we can go up to 65,535. So interfaces comes under directly. You can't use interface. Under VPN Geno, we need to recall interface. Under management part, we need to recall interface. Service part, once we try to onboard and do the configuration of, you can say, of the branch site. So first thing we will learn, in as multiple things we will learn here. I'm just giving you overview because some are joined late. I will not go in depth today, but tomorrow we'll understand entire functionality. After that, we will set up the lab and we will start understanding. First part, tomorrow we'll discuss what is the function of vManage, vSmart, vBond, what all things comes under there, one part. How that is going to work. For that, I will set up a lab. I will show you how to do that setup part. How that is going to interconnect, everything we will discuss. And then we'll understand what is transport locator, what is DTL datagram, transport layer security, what is OMP, which type of configuration we required, everything. So today I'm going with the overview, how that is going to work. And what are the role of the switch here? What is the part of the HQ router? Where we need to configure OSPF, where we need to configure default route, how to establish reachability. We need to have the reverse path also, otherwise that is not going to work. Once we'll understand this part now. So understand one thing. We have only graphical user interface for vManage. In our SD-WAN. In our SD access, we have